Welcome to our channel Quaint Cosmos. Today's topic of discussion is why the electric field strength of a dipole decreases rapidly. So first let's discuss what is dipole. So a dipole consists of two equal and opposite charges separated by a small distance. Okay, so that means the magnitude of the charges should be same and they should be of opposite nature. If one is positive, then others would be negative. And the distance of separation between them is small. So you know that whenever there is a charge, so around that charge, field strength means electric field exists, and the strength of the electric field decreases as you move away from the charge. According to the formula, that formula was obtained from Coulomb's law. What is Coulomb's law? F is equal to K into product of the charges divided by square of the distance between the charges. That is Coulomb's law, and from there the field strength, electric field strength, if you calculate, then that is equal to force per unit charge. So that equals KQ by R square, means the square of the distance. Okay, so that is Coulomb. That is electric field strength. That means the field strength decreases with 1 by R square, with this ratio 1 by R square. So it is inversely proportional to the square of the distance. So that way field strength decreases. But in case of dipole, similar way you should proceed to calculate. You have to consider both the charges. You have to consider the electric field strength of both the charges at the same point. That way you need to proceed to calculate the electric field strength due to the dipole, means due to both the charges. That way you need to proceed. But you know that positive and negative charges are involved here. That means the direction of forces will be opposite to each other. They won't be of same direction. And that is one reason why field strength decreases with the distance rapidly as compared to a single charge. Here actually a comparison is being made. If there is a single charge, what happens? If there is a dipole, what happens? Okay. So a comparison is being made in this video, okay? The topic of discussion is nothing but a comparison between a single charge and the dipole. So I have mentioned that forces, the direction of forces are opposite. Again, if you consider the mathematical formula, then in case of a single charge, it is a proportional, the field strength, electric field strength is proportional to 1 by R square. But in case of a dipole, it is proportional to 1 by R cube. But the numerator changes actually. In case of a single charge, in the numerator, what appears is the charge of the object. Okay, and in the denominator, R square is there. But in case of electric field strength of a dipole, in the numerator, different thing appears. That is the dipole moment. Dipole moment means the product of the electric charge and the distance of separation between the charges. That is known as dipole moment. So here in this case it is a dipole moment divided by R cube, proportional to. Okay, one constant is there which is equal to 1 by 4 pi epsilon 0, where epsilon 0 is the permittivity of the vacuum. Anyway, so let's discuss only about the distance. So you can see that in case of a single charge, it is proportional to 1 by R square, but in case of dipole, it is proportional to 1 by R cube. So there is one extra 1 by R in case of dipole, and that's why the rate of decrease of the electric field strength is rapid, because one extra term is there, 1 by R. This is the reason. Okay, since opposite charges are involved here, that means at any point if you calculate the field strength, then it is nothing but the vector summation, vector sum of both the charges, means vector sum of the effects of both the charges, or vector sum of the electric field strengths of both the charges. Okay, and they cancel out. And if distance is much, distance you should actually make a comparison between the distance which we are talking about right now. That distance is much more greater than, means very greater than the distance of separation between the charges. Okay, distance of separation between the charges. So this is the reason. Actually, opposite charges are involved. That's why field strength decreases. But if you consider same charges, like charges, okay, either both are positive or both are negative, in that case this thing doesn't happen. Field strength does not decrease. Instead, it should increase because two charges are involved. Okay, so this was all about this topic, and if you want to learn about the practical application of these things, or in nature, does it happen or not? Yes, in case of water, if you consider water molecules, then due to this nature, due to the presence of dipole nature of water molecules, they are able to dissolve substances greatly. Okay, water molecules are capable of dissolving substances easily just due to this property, dipole. Again, in case of signal generation, radio antennas are used. Means actually, these dipole antennas are used to generate signals in few cases, not in all the cases. Again, if you think about the magnetic field of our Earth, then dipole of the electric field of our Earth that shields us from the solar radiation. So in many cases, you can easily find the application of this dipole moment or dipole. Okay. Anyway, so this was all about today's topic, and this is the end of this video. Thank you for watching this video.